Lesson 108, Introduction to Coordinate Space. So when you have a coordinate in space, you're going to have an x, y, and z. So when we write the coordinates, we're going to have three numbers. The first one is your x, the second one is your y, and the third one is the z. The coordinate plane in 3D has the x, y on a flat plane. This would be x and this would be y. So if you can imagine kind of laying it down, and then z will come up out of the top of it, off the origin. So the y gets the y-axis. The positives are on the right side, and the x, we count along this way. Now, one thing you might want to remember is that these little hash marks I draw parallel to the y-axis. That's just something I do to help me see those points going out this way. So the positive goes 1, 2, 3, 4, 5 this way. I'm just going to put 5. And then the z goes straight up and down, just like 2D. Okay. So let's say that I wanted to graph the point 3, 2, 4. So the y value is 2. So I come over to where y is 2. Now you know how when you do on the xy plane, you do the x and then you go to the y and then you draw your point. So I'm going to show you, you do your 3, 2, 4, and I'll show you how to get to your point once you have those three. So the x coordinate was 3, so I know that x is there, y is here, and z is 4. Now to come together, what I do is draw like a little, it's a rectangular prism with these points. So if you go straight up, like you're parallel to the x-axis from the 2, and then across from the z parallel to the y-axis, and then you're going to do parallel to the x-axis, and then I'm going to do from the x point parallel to the z-axis. I'm just drawing this little three-dimensional figure here. And then I draw a parallel to the y from the x. From the y, I do parallel to the x. And then now I have these coordinates here that are where those lines intersect, and now I'm going to draw my final vertex. The last one will be the point. So from here I'm going to go across parallel to the y. From here I'm just going to go straight up, and from here has to be parallel to the x. So right here is my point, 3, 2, 4. That might be, a hard way to do it, but that's how I do it. Also, I had some kids we watched like a video online, and there was a little, I feel like this isn't quite right because this should be skinnier. How come?
Oh, so that's the center.
Whoops, it should be right there.
No.
I think I did it wrong. Let's move it over.
So that's like the inside of the cube?
Yeah, no, it's on the, so basically, let me see if I can, it should be right there. Basically, it's where all those points come together. So the 2, the 3, the 3, the 2, and the 4.
Yeah, but now that X is going to left, well, it's almost like the Y is adding to X, but not,
Okay.
because I thought that's what we just said.
Okay. There's a lot of math that we can do in the coordinate space that I want to go over. And again, we'll talk about it after. If you want to write the equation of a line in 3D. So remember in 2D it's y equals mx plus b. This one is xyz equals x sub naught, y sub naught, z sub naught, plus t and d sub 1, d sub 2, d sub 3 as a point. So the x, y, z, so the x naught, y naught, z naught is a known point on the line. It reminds me of the y-intercept. D sub 1, D sub 2, D sub 3 point is called a direction vector. I'm going to go over how to find that vector. It's found by subtracting the corresponding coordinates of 2 ordered triples. So it's found by subtracting the coordinates, I meant corresponding coordinates of 2 ordered triples. So if you have 2 points on the line, you subtract their coordinates and that will be your direction vector. So you could write it 2 different ways because it doesn't matter the order you subtract them. So the direction vector, because it's a line, it can go in different, it can go one way or the other. So you just subtract them, and some of us might have it look different than others, but it'd be the same. So I'm going to give you one example. Name 2 collinear points with point R, 3, 5, 7, and S, 4, 6, 12. So if we know the equation of the line, then we can just find 2 other points on the line. So the direction vector, d sub 1, d sub 2, d sub 3, is the difference between these 2 points. 4, 6, 12 minus 3, 5, 7. And I picked that order just because I wanted to have positive direction vector. I didn't want to have to deal with negatives. So 1, 1, 5 is my direction vector. So to write the equation, we just say any point on the line, x, y, z, equals, we put a known point first. Now we know 2 points. So it doesn't matter which one you pick. I'm going to pick the 4, 6, 12, and you could pick the other one, plus t times this direction vector, 1, 1, 5. So to find 2 points, we just plug in a number for t. Any number besides 1, because if you plug in 1, well actually, could you plug in 1? You'd get 4, 6, 12, which we already know. So we need 2 different ones. So if we plug in, so let me just underline this and say this is the equation of the line. So if t equals 2, let's just do 2. We have our new point, x, y, z. Well, I'll go down so we can have the room here. X will be 4 plus 2 times 1. So we take the x part of each point, 4 plus, and then we're going to do our t, which is 2, times the x value here. So our new x value will be 6. And then we have our y value would be 6 plus 2 times 1. So 8. And then the z value will be 12 plus 2 times 5, so 22. So another point on the line is 6, 8, 22. And then we could use maybe t equals, wait, if I did 1, I would have 5, 7, 17. That's different. We could do 1. T equals 1. So we would have 4 plus 1 times 1, 6 plus 1 times 1, and 12 plus 1 times 5. So we'd have 5, 7, 17. So those are 2 points that are collinear with these other 2 points because they're on the same line. And that's the end of the lesson.